I can hardly believe that I told you to have fun with these, and we didn't go over a very important example.
What would you do with a brain if you had one?
Okay, then. So let's actually do this now. This is example 3 in the book on page 159. So check this out. We've got f of x is 2 to the x, and we want f prime of 0. In other words, we want the slope of this curve at x equals 0. Okay, so let's do our derivative. So f prime of 0 is going to be the limit as h approaches 0 of f of a plus h, which is going to be 0 plus h, minus f of a, which is going to be f of 0, all over h. So we can say that's the limit as h approaches 0 of just f of h minus f of 0 all over h. Okay, so now, what's f of h? Well, it's 2 to the h. So we have limit as h approaches 0 of 2 to the h minus f of 0, which would be 2 to 0, which is 1, over h. All right, now, if we evaluate this, you plug in 0 for h, and you get 2 to 0, which is 1. 1 minus 1 is 0 over 0. We can't do it.
Nice try, but I'm afraid you can't do that.
Okay, so what we need to do instead is we need to algebraically manipulate this so that we can cancel the h. But once again, we can't do it.
Inconceivable!
Okay, so what will we do? Well, we have two options. One, like we did in the very first section of the chapter, we just start putting h values in that get closer and closer to 0 and see what this whole fraction ends up equaling. So if you look on page 160, that's what they're doing. They start with 1/10, and you put 1/10 in, so 2 to the 1/10 minus 1 over 1/10, and you end up with 0.718. So you put in 100th, and you get 0.696. Put in 1,000th, and you get 0.693. Put in a 10,000th, and you get 0.693 again. So basically, we've settled to one particular value, 0.693. Well, let's try it from the other direction. So we're going to go from the left of 0. So negative 1/10, negative 1,000th, negative 100th, negative 1,000th, negative 10,000th, and we end up approaching the same value. So what we just found out is that this limit actually equals approximately 0.693. And in another chapter, we're going to find out that the exact value is natural log of 2, which is approximately 0.693. How did he do that?
He's laying back in the cot, peeping at this here homie. Yo, pop me some cheddar. Some player haters be throwing salt in my game, grilling me over my gear. Not needs to be Mac in style.
Yes, exactly. Okay, so let's take a look at this graphically and see what just happened here. So now our function f of x equals 2 to the x is our old favorite where we have 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. So it's our standard y equals 2 to the x graph. Now we're looking for f prime of 0, which means the slope of the tangent at x equals 0. So we're looking for the slope of that blue line, which is the tangent at x equals 0. Notice the slope, natural log 2. Okay, so remember, the slope is the slope at this infinitesimally small x value. So what we're going to do is we're going to zero in on this x value. So we could start 1 apart, and then we start 1/10 apart, and 100th apart, and 1,000th apart. So if we zero in on this particular x value, we're going to see graphically that the slope of the red curve will end up equaling the slope of the blue line. And watch as we focus in on this point right here. Okay, so now notice we're getting in a little bit closer, which basically means in my graph I'm making the x values smaller. Okay, a little closer. A little closer. What's happening here? Well, we're only going from 0 to 0.5 here instead of 0 to 5. So we're basically 25 times in. Well, what do we see? The curve is looking flatter. It's looking more like the straight line. Well, let's keep going. Okay, same thing. The closer we get, the flatter the curve looks. See, now the curve is looking really close to this straight line. Get a little closer. Get a little closer. Now you can hardly tell the difference between the curve and the straight line. A little closer. Here, the curve and the straight line are virtually the same. This is just like if you look at the Earth from space, you can see that it's spherical shaped. But when you look at the Earth from ground level, the curve of the Earth doesn't really look like a curve. It looks like a straight line. Well, that's what we're doing here. We're approaching 1,000th, and when delta x approaches 1,000th, then the slope of this curve actually resembles the slope of the straight line tangent. Okay, so now have fun with these.